The question from rotational motion is like this: a solid cylinder of mass m rolls down an inclined plane without slipping. If the height of the plane is h, find its rotational kinetic energy at the foot of the plane. Let us try to solve this question. Now, if we try to visualize what is given in the form of a diagram, many a times we have seen in the previous lecture also the same situation, but still, say the inclined plane is theta and the cylinder is placed at the top at a height h. This is what is given. Now, since it is starting from rest, therefore, when it reaches the foot of the plane, it is gaining kinetic energy. Gain in kinetic energy is possible only if there is a somehow there is a loss in potential energy. So, what we can say, loss in potential energy is gain in kinetic energy. Now, since it is rolling without slipping, so the kinetic energy will have two components. Therefore, if I say loss in potential energy, so it is mgh, and gain in kinetic energy two components, translational half mv square and rotational half I omega square. So, that is nothing but half mv square plus half I is m r square by 2 omega square. Care has to be taken that here we are not having r. So, what we can do is we can write this as half mv square plus 1 by 4 mv square, because r square omega square is nothing but v square. So, this is nothing but we get 3 by 4 mv square is mgh. This is what we get, one equation. Now, rotational kinetic energy. How much will be the rotational kinetic energy? Just now in the previous equation, we wrote half I omega square as 1 by 4 mv square. Therefore, 1 by 4 mv square from equation 1, what we can say is from equation 1 mv square 1 by 4 mv square is nothing but mgh by 3. Therefore, rotational kinetic energy when it reaches the foot of the plane is nothing but mgh by 3. That is how we can use the concept of loss in potential energy is gain in kinetic energy, and we can solve such problems.